Hello, everyone. You're on the Z conference on blockchain community booth. I'm SPitkevich. I'm leading blockchain practice at EPAM, and I'm also blockchain professionals community lead. And today we are going to speak, and it's our second speech about blockchain reference architecture. We've already had one talk where we've been explaining the overall approach of the reference architecture and requirements to our solution about functional and non-functional requirements. And today we were going to look deeper and see what are the runtime architecture of the blockchain solutions and what components we should define, and also see to the technology and development architecture parts, how to facilitate the proper blockchain development. But let's start from the beginning and see the background of how this reference architecture work. The thing is, our company is professionally delivering blockchain solutions. We are providing services starting from consultancy and designing blockchain applications towards implementation, testing, and we are also doing optimization support. And well, as you can understand, delivering multiple solutions at the same time, being professional in application delivery, we would like to apply certain standards to that. And also, we would like to secure that the designs we propose to our clients are good designs. And we are trying to define the way of thinking for our solution architects. So they will come up with the design, like with the robust, with a good design, and also specific to what our clients need. And in the past, doing that as a state of art every time, we noticed that obviously there are similarities, and also that the way of thinking and the components which we need to define and capabilities we need to define are the same, and it's logical, like any architect knows that. And so far, we started to describe those parts and to combine that in so-called reference architecture framework. That's one of the assets we have at EPAM to supply for our delivery. We also have delivery methodology. We have the process how to describe the pre-discovery and discovery. We do have testing methodology, and we do have some operational manuals or operational framework which helps us. So the reference architecture is connecting to those frameworks. It doesn't exist in a vacuum. It's a part of the overall EPAM approach of the delivery in blockchain solutions. So on our first talk, we were actually speculating over the reference architecture structure, starting from DLT platform, and saying that there are specific blockchain services which lays in the core of any blockchain system we're defining. And you should know them. Those are the smart contract defined business logic, consensus mechanisms. So all those features which belong to the blockchain technology, to the blockchain concept. But the good solution consists over other parts. First of all, obviously, your DLT platform should reside on infrastructure, which is much in the need. And basically, it should describe like what any solution is working with the data. And those data should be created, maintained, and stored correctly, structurally, securely. And it also means that we need to define this data architecture part and the integration part. Obviously, none of the solution exists in whole, like in its own. Any blockchain solution of enterprise grade will need to exchange data with other client solutions. For example, if we're building something for banking, that would be core banking software, or probably some other banking tools which are used by bank operators. If we are speaking about automotive, well, any industry has their specific applications which are supporting for their product process life cycle for what they do. And blockchain solution obviously integrates with that. It's obviously taking part of our client's landscape and should be well connected and integrated with those already existing applications. So it's absolutely necessary to define the integration layer. Then we are moving, yeah, obviously, any of our solutions will have the user interface. Certain I would say user interface can be different. If we're speaking about IoT devices like smart meters, that will have the connect to the smart meters and will interact with the meter itself. It might have the obvious part, web interface and mobile interface. There might be that the presentation there is like certain APIs with the certain functionalities, but we must think about that too. That's how our uh, application basically presents its the results of its working. And obviously, all our like the complete solution needs to be secure. And this part is speaking about the what the key creation, the key storage, rotation of the keys. So all like supporting of like crypto keys life cycles. That's also speaks about the secure, like the procedures of using that and encryption, which is selected. And obviously, like in some cases, it speaks about the secure development. And last but not least, all of this and like needs to be delivered, and after go live, it needs to be operated. And while we're speaking about the architecture of the solution, there are different aspects of that. There is an aspect of the runtime, and there's an aspect of the creation of the solution. And that's exactly the topic for us like for today. So on this moment, I would like you to understand that yes, as a part of our reference architecture, we're also thinking of how to deliver blockchain solutions and how to operate them when they're live. So that shows us the top level of our reference architecture framework. And the topic of today is actually runtime and the development architectures. And we are starting from runtime. And if you ever developed blockchain solution, you know that it's a very important topic of how the solution like would work, would be executed live. You have to design separately this runtime life of your solution and to be very careful with the moment of how solution is going live. Because normally, and even independently of how private and how permissioned your solution is, you need to develop the specific procedures of how you will roll out your solution. Because at that moment, your initial block, like what you don't have the length of the chain to secure the chain itself. In many cases, you have multiple participants to do the rollout because it's a network. And you have to design how the nodes of your network are starting to work together from the very beginning. And for that, they you should create the specific designs for that. And we are trying to coach our architects of how to go from this process of thinking, what needs to be defined. And again, what we are saying that obviously your runtime architecture consists out of the three main parts. First of all, channels. That's how your solution is going to communicate to external world. Uh, that's very similar to the presentation layer. It speaks about are you going to use web interface? Are you going to use like mobile interface? In some cases, there would be the specific networks and specific protocols, for example, for like game controls and something. Are you working with some special hardware, smart meters, devices? All of needs to be like described in your runtime architecture, and the processes of dealing per channel needs to be defined. Then we are speaking about a functional layer. And sorry, but that's outside of our scope today. Functional, that's well, we're speaking on the business track about this. And that's basically what your solution does functionally. And that's very specific to the use case, very specific to the client, very specific to, and basically we are, when we were speaking about the requirements, we were speaking a little bit about the functional aspects of the solution. But today we're trying to focus on technology architecture. So, well, we must know that our functional layer has to be defined. And we will switch to the core meat of presentation today on a technical runtime layer. And what do we need to define here? Basically, well, almost all of the aspects which I was showing you a minute before on overall reference architecture, but specific to the runtime. First of all, well, everything relates on infrastructure. So we will need to describe how to build the underlying environment to facilitate the solution. Here for the runtime would be requirements and would be designs of your production environment. Then data, how to manage, secure, and analyze data kept on-chain and off-chain. And here we will speak about archiving. Here we will speak about data monitoring, data consistency, the requests which we can get to the system, like on-chain, off-chain, the sizes of the data, the structures of the data. So all the data management part. Then obviously security, solution security, how to ensure that our solution protects users, system, data, how does it interact with IT, all the procedures and all the checks with the corporate security, they need to be done. And remember, we're speaking about runtime. So specific to the your application execution. Then presentation layer, like a user interface, it should be well defined of what data we are providing to the interfaces, what we support, what versions of the user interface we support, what do we need, and how do we facilitate that in our production environment. And also think about the aspects of rolling out the upgrades, of doing the technical maintenance work. What do we do on our channels? Like, what do we do? Like, if we plan for downtime, or if it's unplanned downtime, what will happen with our channels? It needs to be designed too. Then integration layer, and that speaks precisely. Like previously, we were defining the aspects of how we are integrating, but here in runtime, we are defining precisely what interfaces are brought into the scope. What are the parameters of those interfaces? Frequency, if there's a frequency, how does it monitoring aspects of the integration, the aspects of disaster recovery upon the interfaces, the aspects of the availability of the interfaces, all needs to be defined. And on top of that, very frequently, when the blockchain solution goes live, it works certain time in a gray mode where there is like main current banking solution, or not banking, like client solution, but what is working right now. And then in parallel, blockchain solution is doing almost the same job. And that allows the client to realize if the blockchain solution satisfies the need. And it allows client to make a decision to shift towards the blockchain solution and decommission to the old application. And here on integration layer, also on a data layer, but mainly on integration layer, we are describing those aspects of working in parallel with other solutions and comparisons which needs to be done to make a decision if solution works well or not. It should really be defined how it integrates with the old, with the current system on a level like on DLT level. And DevOps aspects of the runtime, how we are rolling out, like how we're deploying new pieces, what needs to be done in a solution. And if you ever developing, you might know that there are quite some of the specific in a solution deployments, and the different foundation technologies, they approach it differently. When we are speaking about like Ethereum network, our smart contracts, which were created to be run runtime, needs to have the special design to allow new versions. And those new versions and the rollout of the new versions of the smart contracts should take care of moving balances from an old contract to the new contract. Otherwise, the whole history would be lost. So those aspects of deployment of the new versions and operational stuff also need to be described in runtime architecture. And we can look to the solution, like to our blockchain solution. From the parts, we have runtime architecture. And around that, we have like development and operation. While we are developing solution, there are also quite some of the requirements of how to do the development nicely, how to do the development which would be controlled and predictable. And that leads to the controlled and predictable operations. And it also leads to the high quality maintainable solution. So what for the rest of our time, we will look of the details, and I'm now revealing the second layer of our reference architecture, and we will look at both runtime and the DevOps side. So this is the second layer of the runtime architecture for the blockchain solutions. And you see that I've already been spoken about the first one, speaking about the presentation, integration, data security, infrastructure, and core, which is like we mark it here, the centralization. And basically, what do we need to define there? Well, we're starting from our core layer of the centralization, the aspects of the smart contract work, transactions, and how the transactions are processed as a whole, consensus, how the nodes are run, and the government needs to be defined. And that's specific to DLT. And that's here the specific, like what the blockchain architects needs to work. Then it's connected to the infrastructure layer. And here we are defining if like what every time designing the solution, you're designing that according to the client requirements and according to the client need. And please understand that here we are defining the menu, what can be done. It doesn't mean that you have to have all of this. It means that you have to think about all of this and consciously decide, do you bring it in or not? So when I'm speaking about the infrastructure, containerization, disaster recovery, infrastructure as a service may need to be defined. And like more the higher quality, like the more you have, the higher quality your solution is. Then the data, and in the data we're discussing storage, the data transport, enterprise data models, if they exist, security of the data, and the data archival. And there are specific archival patterns for the blockchain solutions, because if we're developing the enterprise solution and it's going to reside in this life for a long period of time, your chains and your data storages, your node databases, your node persistence layer appear to be huge. And you need to know, like sooner or later, you will meet the situation. Probably when you're deciding or designing the pilot solutions, you can skip this. But when you are going live and you are thinking about like 5-10 years of operational life of your solution, you need to define the archival mechanisms. Then integration. And obviously your system API management and 3 types of the APIs, channel, process, and system APIs needs to be defined. And here the integration architects should work, and the set of the integration documentation for your solution should exist. Then we are speaking about the security aspects, and they are the security architects. And frequently this job is partially outsourced. But anyway, while you're designing the solution, you have to think about this. Remember, we're not dictating that it must be done. We are trying to structurize the way of thinking of the architects, trying to outline the scope for them. And here, well, obviously, authorization authentication for any solution needs to be described well. Key management procedures. For that, very frequently, the vendor software is used. Sometimes, like DLT foundation layer doesn't always provides you the services for the key management that's normally consumes the case. And the decision of what key management solution you are going to use lays upon architects. And obviously security operations. All those procedures of the key creation, key maintenance, rotation of the keys, all the separations of duties, and all this, well, in some cases, multiple key layer structure, and the procedures what to do when the key is lost needs to be defined. When we're speaking about a production solution, that's very important. Like on a pilot, you can kind of play, and also while it's not live, you can play with like embedded keys, with not rotating keys. But as soon as enterprise level you're going to go live, the security aspects appears to be huge, especially when you're speaking about the publicly available solutions. And last but not least, presentation layer. In presentation layer, you speak about the rendering and interaction, about the personalization aspects of your solution, and about the content management part. And this is like, well, totally separate, but and normally doesn't have much of the DLT specific. But recently, we started to learn a lot about the front-end augmentation and about DLT solutions, where the targeted layer, the targeted solution layer is is a top layer of the web applications, where we augment the top of the websites. In this case, the presentation layer here, that would be huge. In the traditional core blockchain solutions, where the majority of the blockchain lays at the back end, that's thinner, but still needs to be described. And I'm trying to move forward development, the DevOps aspects of the solution. Very frequently, we're talking to our delivery managers who are complaining about, mess of the project, about the inability of the organizations to structurally deliver blockchain solutions. Many of our clients trying to do that themselves, and quite some of them are asking help for this, because it's difficult. It's difficult to build a solution combining that, combining the efforts of the various companies. It's difficult to take care of all the aspects of the blockchain solution development, and it's even more difficult to think about its operations. I'm trying to fit the story in a time given, so I'm trying to just very high level outline what we are speaking about. And obviously at our blockchain professionals community, we are frequently speaking about those topics. Join our sessions if you want to know more. So on a very top level, we might think in our development infrastructure about software generation. Some parts of our software we don't need to put our hands on. That can be after generated. And here we can, after generate the configurations, we can after generate the code. We need to take that into the menu of what we may do. Build an integration, obvious. Compilation, continuous integration, orchestration, build, development integrations, how we are combining all our tools together with the testing tools. That needs to be defined. And architecture work, like the work of the technology architect, is very important here. Test automation, logical and obvious. We always targeting 100% unit test automation. We are trying normally to achieve not less than 80% for service and API tests, performance testing, penetration testing. This all needs to be designed in the details. Change control, how we are going to distribute the versions, how we are going to do the version management. Remember, we have many nodes. There can be different types of nodes, different clients. It needs to be designed. Artifact management, where the distributions would be downloadable, how they are going to be downloadable. Delivery management, the bread and butter of our delivery managers, releases, application lifecycle, knowledge management, change control also appearing to be here. The huge topic needs to be designed. And then IT operations, monitoring, scheduling, availability, performance, infrastructure as a service, all those aspects needs to be designed in the details to be manageable. And last but not least, ecosystem management. How we are including new members, how we are developing ecosystem, how does it evolve the roadmap for ecosystem, and the platform support, because by having multiple members, you probably support many platforms and still needs to be the same nature of the code. All those aspects needs to be defined well. And that's a huge work of the architects. But here, again, that's a second layer. We are trying to describe the way of architecture thinking here. And we are at the end of our presentation. And guys, if you'd like to know more, reach out to our blockchain professionals community, reach out to myself, and we can share what our thinking about that, and we can proceed with our framework further. Thank you for your time. That was Alexandra Pitkevich. Bye.